Hi, my name is Michał. I'm from Red Hat, and I'm here today to show you Quarkus, a project that I have an opportunity to contribute a bit lately. What is this Quarkus? Quarkus is an application generator or a full-stack framework. You can think of it as an alternative for Spring Boot or Thorntail or whatever. It is, as everything from Red Hat, it's 100% open source, but it's still in beta. It doesn't have a final release yet. Let me start with a few words of motivation, why a new project in this field has been started. So the motivation is the cloud, and more specifically, Java in the cloud. Java is a great language. Sometimes requires you to write a bit too much of a boilerplate, but it's easy to read, write, or debug. Has a plethora of great libraries, also IDE support, but it runs on the top of a JVM. And JVM itself adds some weight to your Java application. And even more importantly, probably, Java frameworks used to do a lot of initialization in the runtime, on the startup. So these two lead to high memory consumption of Java applications and long startup times. This is okay-ish if you have your own server and you can just buy RAM to it. But if you move your application to the cloud, this starts to be costly. So this is the problem we're trying to solve here. And we do it with GraalVM. GraalVM is a new Java VM from Oracle. And among other great features like Truffle, for example, it also has native image and substrate VM that allow efficient ahead-of-time compilation of Java applications to native binaries. And this gave the idea to a few Red Hat people to start a new project that would bring the benefits of native compilation to server-side Java. So here are some numbers. So for a simple RESTful application written in Quarkus, if you run it on a normal JVM, because you obviously can, it's normal Java, it will be able to fit into 74 megs of RAM after starting and handling a request, just to rule out lazy initialization from the equation. And this is total memory, including heap, including any code cache, JVM stuff, whatever. If you compile it to a native binary, it will fit into 13 megs of RAM. And this 74 is actually much better than most similar frameworks currently available. If you add some database capabilities to your application, it will grow. For the JVM execution, it will grow to 130 megs. But if you compile it to a native binary, it will be 35 megs of RAM. So this is what we gain in terms of memory, and this is what we gain in terms of time. So again, the measurements were made after starting and handling a request. So a simple REST application was able to start and handle a request on the JVM in 3/4 of a second. But if it was compiled natively, it was 14 milliseconds. And if you start to talk to the database, in the JVM mode, it will be 2.5 seconds, and in the native mode, it will be a few tenths of milliseconds. Still, so this is really fast, in my opinion. This makes like server-side Java applicable for user-facing serverless, because the user won't even notice that server was started during handling of his request. So this is what we gain. And how do we do it? The other plus side of Quarkus is that you can use the model that you already know. You can write the stuff that the way you used to do it. So you can expose RESTful APIs with JAX-RS or Spring MVC if you prefer Spring MVC. But underneath, it will be translated to JAX-RS anyway. You can inject dependencies with CDI, but you can use this auto-wired, etc., and scope-defining annotations from Spring as well. You can talk to your database with JPA, but here Quarkus comes with a nice add-on called Panache that I will show you on the demo. There's also Spring Data JPA support, but I don't know what is the current state of it. I mean, how stable that is currently. And you can also, if you like programming reactively, you can do it with Vert.x. There's Vert.x underneath it all, and it's also exposed for the users. And there are many other extensions, because that's how Quarkus features are called. For example, Cogito is for doing BPM stuff or joules. There's something for AWS Lambda, some Kotlin support, etc. I won't go through all of the capabilities, but I'd like to spend some time on MicroProfile that is also supported by Quarkus. MicroProfile is a set of specifications for working in the cloud with server-side Java. I will just name a few specifications. One of them is MicroProfile full tolerance that lets you define circuit breakers, bulkheads, fallbacks, etc. with annotations on your methods. With MicroProfile, you can also secure your applications with MicroProfile JWT. JWT is for JSON Web Token, which is a solution in which you can send a token that is signed by the trusted authority together with a request, and then all the applications that will handle the request will be able to verify the token by just checking the signature, and will be able to unpack, for example, user roles from the token, and won't have to go to the authentication server for that. You can also use MicroProfile open tracing that lets you track what's going on with a request when it goes through your system. I'll show you that on the demo if I have time. So basically, if you add it to your application, the application will start to report spans of time requests spent in the application to a server like Jaeger. And then in Jaeger UI, you will be able to view what happened with the request. Another specification is for metrics. MicroProfile metrics by default would expose stuff like garbage collector stats, memory usage, or thread count, etc. But you can easily extend what's exposed by some simply extend what's exposed, and you can gather all this information in a Prometheus server. Another one is MicroProfile health check. MicroProfile health that exposed health checks. It's just basically some endpoints that say that the application has started or is live. And they're especially useful if you work with Kubernetes, because you can use them for liveness and readiness probe, so that Kubernetes knows where to start putting traffic through your application, or when to wipe it out and recreate the pod. There are also some specifications for reactive programming, that is reactive messaging or context propagation. With reactive messaging, you can talk with Kafka or anything that works with AMQP or AMQTT. With context propagation, you can propagate context, like, for example, Hibernate session to an async invocation. On code Quarkus.io, you can generate a Quarkus application, and then there you can also see the list of all available extensions, because you can just select them to your generated application. So these were a few words about the features. Now let's handle what's more in Quarkus. So Quarkus is also designed for productivity. And the biggest feature in this area is the development mode. So you can start a Quarkus application with a special Maven or Gradle command. And then you just start it and start coding. And you don't have to rebuild your server. It will restart automatically on changes. And I think I'll show that to you too. The variety of changes that are supported is really wide. So for example, you can have also database schema changes done on the fly. Also, in this special mode, Quarkus application listens for the bugger on port 5005. Another feature that helps with productivity is the way it's configured. So as many modern frameworks, Quarkus doesn't need any configuration if you don't do any usual stuff. You need configuration, for example, if you want to talk to the database or Kafka, but by default you don't need anything. There's one configuration file for everything, and it's compatible with MicroProfile config, and that means that you can override config properties with environment variables and system properties. Also, Quarkus also comes with helpers for testing. There's a JDD4 and JDD5 extension, and there are also tools to test your application in the native execution of your application. So if you annotate your test with a specific annotation, it will be run against a natively built binary. But there's one gotcha here. The test classes are not put into the native binary, not to interrupt the ahead-of-time compilation. So it's like client-side testing. You can use, for example, the REST API to test it, but you cannot grab a specific CDI bean and do anything on it. So now let's jump to what's under the hood, how it actually works. So as I said previously, the native execution is from GraalVM, substrate VM. This is how it basically works. So GraalVM takes all the JDK classes, your application classes, etc., and then analyzes the graph of what's going on in the runtime and produces a native executable. And by the way, eliminates any unused classes, fields, etc. That's why we use much less memory in the runtime with the native binary. But obviously, it has some limitations. So for example, without any registration, reflections won't work. You have to specifically register some classes for reflection if you want to do such things. Similarly, with dynamic proxies, there's some stuff that is not supported at all. And static initialization is done on the build time and not on after start. So full stack framework is one name for Quarkus, but you can also look at it as a framework for creating extensions that work with this in this native mode. Generally, Quarkus does class path scanning at the build time, provides means for registering for reflections, etc., and adjusts the dead code elimination. And this is how it looks in a big picture look of it. So there are Quarkus extensions like RestEasy or Hibernate, etc. Beneath that is Quarkus core, which handles the provides tools for registering for reflection, etc. This in turn uses Jandex for indexing classes, annotations, etc. Gizmo for class bytecode manipulation, and Graal SDK itself. And there's also a piece called Arc, which is a dependency injection implementation, almost CDI implementation. And as I said previously, you can both run it on a normal JVM and natively. So this is what it is, and I'd like to show you now how it actually behaves, how you work with it. So for the demo, I'll live code a piece of a system, a search engine, in which you can enter a search term and get some page addresses as a result. And based on this search terms, you will get a personalized advertisement on the right. This is how it will work. So there's a front that I have written already written. And front service is the thing that exposes this web page that we've just seen, and it asks the search engine that we will write for the results, and the search engine uses the database to gather the results for the search term, but also forwards the queries to a Kafka topic, and then these queries are consumed by the ads service that creates a personalized ad. So let's jump to it. Okay, I will start by generating a Quarkus application. Are these letters big enough, or should I increase the font? Like that? Okay. So as you can see, it's an empty directory, so let's generate a Quarkus project. One can do it with Quarkus Maven plugin. Then there is a version that I want to use, and create goal handles the creation. And I want to add a Quarkus RestEasy JSON extension to be able to expose JSON stuff with REST. So if I run this, I will be asked for group ID, artifact ID, search, and version. And I can also have a REST resource generated, so I'll use this. Let's call it call, example, search resource. Okay, the project got generated. Let me now open it with IntelliJ. So what was generated is a POM file. Let's start with a POM file and then go through the other elements. So POM file has some properties like Java version, etc., but also defines a BOM. BOM file is a kind of a POM file that lists versions of dependencies, and then when you add dependencies that have their version in the BOM, it's enough to import the BOM, and you don't have to specify the versions in your dependencies. So yeah, there is a Quarkus BOM here. There is Quarkus RestEasy extension because I wanted to have this JAX-REST, this REST endpoint exposed, and there is this RestEasy JSON-B that I asked for explicitly. There are some dependencies for testing, and then there is Quarkus Maven plugin for actually building a jar of our application with some Surefire configuration, and then there is a profile for building the native executable here. Again, Quarkus Maven plugin, but with a different goal. So this is the POM file. What I also get generated is some Maven wrapper file, but it doesn't really matter. And I have the resource. It's a normal JAX-REST resource that returns hello. And then there are Docker files. You can use these Docker files to create an image for running a Quarkus application in the Docker. One of the Docker files is for the JVM execution, and one is for using the native binary. And also there is a resources directory, which has application properties, a place for configuring your application. For now, it doesn't have anything. And then there is an example web page here that I will just remove. Okay, so I have this, oops, this is it. I have this search engine running already on port 8080. And this is the default port for Quarkus, so I'll just select a different port for the search service. So Quarkus HTTP port, let it be 8180. And I will just start it, and let's see if it works. So I can start it in this development mode with MVN Quarkus dev. Probably, again, letters are not big enough. Is it enough? So. Okay, started. So let's curl it. Localhost 8080/search, and it returned hello as it should. Now I don't want to return hello here. I want to return some search results. So I will return them as a list of strings and rename the method to reflect that to, for example, search. And I don't want to use text plain. I will use JSON. Now, this is the wrong type, so I'll use singleton list of hello just to see if it worked. Boom. So as you can see, it worked. I didn't have to restart anything. It just restarted some of the pieces of Quarkus itself underneath, and I can just go on. The front service will pass search term and user ID as query params, so let's add them. The search term is passed in a query param called query, and user ID is in a user ID query param. So let's add it like that, and let's just see if it works by returning both of them. So user ID query. Here it is. Oops, something didn't work. Yeah. Yes, and as you can see, there is a nice error message here that doesn't look very nice because my letters are so big, but basically it says why what failed. So it's 2 nulls because I don't pass any query parameters here. So I'll just add them. So let the user ID be Michał and query be query be awesome Java. Yeah, so it work. But let's now maybe split query to keywords so that we can map them to pages. So list of string keywords, query, split, and let's split them on anything that is not a word character. So like that. Okay. And just return the keywords to see if it works. Oh, I have to wrap it into a list. Okay. So let's return keywords now. So we can check it here, but we can also go to the page and see if it worked. Like, let it be native Java, for example, and it returned the keyword split, right? So again, I didn't have to restart anything. I can just go on. Now I want to map these keywords to some web pages. And for that, I want to have database. I promised on the slide. So I will now stop my Quarkus application to add some extensions, because the development mode cannot handle adding extensions. This is the only situation where you have to restart Quarkus. So let's maybe list all the extensions. Quarkus has this Maven plugin and a Gradle plugin as well, but I don't know how it works there. And this plugin is able to add extensions to an existing application, but also list extensions. So let's list the extensions and grab, for example, Quarkus JDBC PostgreSQL. This one. So let's do mvn Quarkus add extensions. Quarkus JDBC PostgreSQL, and I'd like to use Hibernate with this extra add-ons that's called Hibernate Panache. So I'll just type it Hibernate or Panache. Yes, I got it right. So now I can start the application again. So let's just and continue with the started application. So it already started. So let's add some database configuration stuff here. Database configuration is what you probably expect. So there is a data source URL, driver, username, password. I also added a database generation strategy create drop, so that I can do anything I want with my entities, and the database schema will be regenerated on each restart. And now I can add my entity. So let me do this. And I have an ugly name for my entity. It's called page keyword because it maps pages to keywords. And it will have a page address and keyword. And as with JPA entities, I have to add an entity annotation here. But I don't have to add an ID or anything like that. I can just extend a panache entity here. So, and this is it. This is my entity, and this is how I can work with it. So normally I would inject a Hibernate session or entity manager here. I don't have to do it with panache. I get generated some nice static methods that I can use. So let me find, I want to find all the pages that match my keywords. So let me do it. So let me do it this way. So I want page keyword, where keyword is in my keywords list. This is it. Now I have to assign to something. Let's call it a DB query. And it's of type page keyword. Now I have this DB query. I can list what's inside, for example. I could list it, but I can, for example, also stream it. I can also return it by page. So I'll just stream it, and then I will select. I'm not interested in the keywords once again. I'm interested in the pages only. So let's get pages from it. And I want them distinct. I don't want duplicates. I want them collected to list. Okay, so let's try it. It worked, restarted itself, and returned an empty list. That's because that even if I had something in the database, on the restart, Quarkus removed the database and just created the tables for my entity, the table for my entity. So I have to put something in the database. It would be quite inconvenient to put something in the database on each restart. So that's why Quarkus comes with an import SQL file that you can just put into resources. Import SQL. And you can put anything you want here, anything you want to be executed on your database on each start. So I have written some queries to make the keyword page mapping here. And without restarting the application again, I will ask my search engine for example, native Java again. So now I have Quarkus, Spring, Micronaut, MicroProfile. If I do Quarkus native only, I will only get Quarkus and Micronaut. So this is it if it comes to the searching part. But still, we don't have the advertisement for the user because we don't fit the Kafka topic that the ad service is trying to get the queries from, right? So let's see how it works with Kafka. Again, I have to add some extensions, so I have to kill my server for a second. So let's add extensions. And I want an extension for Kafka, and I want an extension for Vert.x. That's because I will be using the serializer from Vert.x. Okay. As you can see, the names are longer, but this add extension works like searches through all the extensions and tries to find a match based on the names that it was given. So let's start it once again. Or maybe let's do it like this, compile. Okay. So now our application has capabilities to work with Kafka. Again, I need some configuration. So I'll add it here. And the configuration again is quite straightforward, I think. So I need to define a connector. The connector that is available to talking with Kafka is small-i Kafka. Small-i is our microprofile implementation that, for example, Quarkus uses, but also many other projects. I need to specify the name of the topic to which I want to write. This is queries. There is Kafka host, and there is also a serializer for the object that I will send. And the name I used for the stream to which I will write is called search thing. So it's search terms. So, okay. Here I have a Kafka consumer that tries to read from this topic, so we'll see if anything is put there. So let's jump to search resource and add this printing to the topic. So for that I will use emitter. Sorry, emitter is this one. Emitter of type JSON object. This is from Vert.x. That's why I added this Vert.x extension, and I will call it query emitter. And I have to annotate it with stream and specify the stream name. This is the same that I put here in application properties. So now I can just simply do query emitter send and create a JSON object that I want to send. So it will be new JSON object, put, and then user ID, and put query. And this should be it. With a bit of luck, it should work now. So let's try. Let's try again the same thing that we did before. So as you can see, the Kafka consumer console consumer showed that user ID Michał queried for awesome job. So this is this part. And now let's see it here if it started working. So so let's query for native. Okay, the results are the same, so it doesn't really matter. But let's query for Java. And as you can see, the advertisements different advertisements started showing up here. Okay, so this is what I wanted to show you in terms of like business logic stuff. Now I'd like to show you a bit of microprofile stuff as well with this application. So I will add all the extensions at once, not to have to restart the application. So I will add OpenAPI, metrics, and tracing. So the extensions have been added. And I need most of them don't need any configuration, but Open Tracing does if you want to put some stuff into the Jaeger instance. So let me add configurations for that. It's again quite simple. There's a service name. There's a sampler configuration. For the test purposes, I'm using a sampler that sends information about every request to Jaeger. It, of course, can be configured otherwise, not to cause performance problems. There is a Jaeger URL here. So let's start the application. Oh, sorry. No, this one. Okay, it started. So let's see, for example, metrics. Localhost 8180 metrics. And I just added MicroProfile metrics to the project, and I have information on loaded classes, garbage collector stuff, and some memory stuff as well here. Okay, another stuff that I added was OpenAPI. So it generated some OpenAPI information. I have one endpoint that on path search exposes a get method and gets query and user ID and returns a list of string, right? Okay, and I also added tracing. I already have my search engine service connected to Jaeger that I have running here. So let me try to do some requests and see if they will start to show up in Jaeger. So let's query for native, for awesome. Okay, Let's refresh this page. This is my front service, and the operation I'm interested in is such. So let's find traces for that. Oh, okay, here it is. So the query was handled in 23 milliseconds in the front service, of which 7 milliseconds was in the search service. Oops. Okay. I could also show you the ad service, but it would be quite similar to that. So maybe let's go and jump to questions directly. Yep. I don't know about Kafka, but many frameworks don't work well on GraalVM just out of the box. Some of them use reflection, for example, and it will not just work. So this is the majority of the work that Quarkus does, is adjusting the things behind the extensions to work well in the native mode. But there's also this hot reload that won't probably work if you just add a dependency. It might work, but it might not as well. So the question is it hard to create an extension? There is a guide for it. It's not very like easy, but there are people from outside Red Hat who created extensions. So if you'd like, I encourage you to do that, and you can get help on, for example, Quarkus Zulip if you want to create an extension. It will definitely help you. So the question is, do I need to rewrite an extension or the framework?
The framework. For example, I have a Hibernate and I want to add this extension of Hibernate. To rewrite this library?
Okay, so the question is, do I have to rewrite a library if I want to make an extension for it? So no, the extensions use like normal community versions of libraries. So for example, Hibernate. Actually, Hibernate is not a very good example because it has some adjustments made to make it work very well. But many extensions are just no code changes in the libraries were made for creating an extension. You can have some how was it called? With GraalVM, you can replace some code that is in the library and put the thing that replaces it in an extension, for example. So yeah, kind of. Any other questions? Yes. So the question is there a support for Gradle? Yes, there is support for Gradle. And of the interesting ones, there's also support for Kotlin, but I've never tried it, so I don't know the quality of it. But it's still in beta, so there are some companies that run it in production, but I wouldn't recommend it yet for some for crucial systems. Any questions? Other questions? Nope. Thank you for your attention. Yeah, as I